Hey friends, it's shear moment diagram time. We're going to do another diagram problem here to practice a little. This is not going to use the equation method, okay? We'll use the graphic method this time, okay? The graphic method. And let's see if we can solve this problem here. So we've got a distributed load. I've got a concentrated load right on the end of the distributed load and another distributed load over here. And then I've got a fixed connection over here on the end. Remember fixed connections, what do you have? You have an AX, which in this case is 0 because there are no forces in the X direction. You have an AY, okay, and we'll have to find that guy, won't we? And then you have, of course, all of this stuff is trying to rotate me clockwise, so I think you need to have a counterclockwise moment over here to counteract that, okay? So on our shear moment diagram, right? So it says draw a shear moment diagram for that load curve. For the shear moment diagram, we're going to have the V graph, which is going to be in kips this time, kilopounds, okay, 1,000 pounds. And then M, which is in kip feet, okay? So here's our graph. So step one is this. Let's put what we call our discontinuities on this graph. All right, so everywhere we think we have something interesting going to happen, we're going to put a discontinuity in there. So I think something interesting definitely is going to happen here. Okay, and I think the end of the beam, that's got to be interesting, doesn't it? Whoa, come on. So something over there, okay? I'm going to get rid of that and get rid of that. Okay, so there's our graph so far. We remember the order of the lines from our last video. This is how these graphs are related. This is the load curve, and the V diagram is the integral of the load curve. The M diagram is the integral of the V curve. A little later on in solids, you can actually integrate that 2 more times and get the slope of the deflection, and then you can actually get the distance that the thing is deflecting. So get that to look forward to. But anyway, if you have a concentrated force, a concentrated load, the next graph down is going to have a linear line on it. The next graph down is going to have a slope, either positive or negative. The next graph down after that line is going to have a parabolic curve, and the next one down from there is a cubic. Okay? So that's kind of a little trick that we remember so we know what the lines look as we go down, because this one has like a horizontal line. So the next graph down, boom, is going to have a slant or a slope line. Okay? All right, so step one. Step one, find global equilibrium. So let's find global equilibrium for this. How about we do one thing here. We've got our distributed load. Let's turn it into a concentrated load. And I'll put it right in the middle, right there. And how big is that? 2 kips per foot times 6 feet of it. That is 12 kips. Okay, so that's how big that concentrated load is. So AY, up stuff has to equal the down stuff. I've got a whole total of 10 and 8 is 18 plus 12 more is 30. So AY has to be 30 kips. I got 30 going down. Now I got 30 going up. So the system is balanced. The last thing to do is find this MA, and I think I'll have to do that with a moment equation. So sum of the moments at point A. And remember, you knock everything out at A except for moments. You can't knock out your ma. Okay, here we go. So I drew that positive, didn't I? So MA. I've got the 12, which rotates me. Oh, that's negative. Minus 12 times 3, right? It's in the middle of the 6 there. I've got the 10, which is negative, which is at 6. So minus 10 times 6. And then I've got the 8 over here, which is also negative, times 10, so minus 8 times 10, okay? So MA, let's see, what is that? 36 and 60 and 80 is, let's see, 140, 176. And that is kip feet, right? Okay. 176 kip feet, 176. Now, if you got one of these wrong, okay, let's say you got MA wrong, If you get one of those wrong, you're not going to get back to 0 over here, right? So there's a check step that lets me know that I've got something messed up. And if you don't get back to 0, I would say that what you got to do is go back and check your global equilibrium. That's where most of the problems are made. If you don't get to 0 on this graph and that graph, probably global equilibrium is hosed up. We need to go check that first, okay? That's the bad news is once you find a mistake, you got to go back to step 1. Ugh. Okay, here we go. So we got a load backpack on, right? I got my backpack on. It's got nothing in it, all right? I'm going to hop on this beam, and I'm going to walk from the left to the right, okay? And somebody's going to put stuff in my backpack, okay? So here we go. I hop on the beam, and then boom, instantly, I get 30 kips upwards. So, whoop, Van Halen force right there. Might as well jump, okay? 30 kips, so I go straight up. Okay, there I am. Now what? Okay, now I'm going to go down 12 kips over this amount here. So I'm at 30. If I go down 12, that's going to take me over here to like 18, isn't it? Okay, but how do I get there? Okay, I have a straight line up here. So my next graph down, right, a straight line, next graph down, is going to be a slope. Because look here, I take a step, 2 kips. Take another step, another 2 kips. Take another step, another 2 kips. Right, so I get this straight line like that. That's perfectly straight, as you can see. Okay, now what do I have in my load backpack? I'm at 18. Boom, I hit 10. So I got to go down 10. Now I'm there. Okay, there's 10. Okay, now what? I keep walking, and guess what? No change, no change, no change. Bam! And then I look at there at the very end of the beam, I got a John Denver force. Take me home to the place I belong on my shear graph, back to 0. Okay, so that takes me back to 0. That's where I wanted to be, isn't it? Okay. Well, so wait a minute. I was at 18. I went down 10. That took me to 8, didn't it? That's 8. Duh. Okay. And so there is my graph. There is my V graph. Okay. Now, what do I have? I'm going to put a little plus in here, and I'm going to put a little plus in here, because that tells me the area above the line is going to give me a positive slope on my M diagram, okay? So my M diagram is going to go uphill, uphill, okay? Now, there's one more thing here that we need to remember, and that's this, okay? There's two ways to bend a beam. You can bend the beam like this, okay? I can put moments on it and bend the beam. Like here's my beam. If I put a moment on it like that, right? Right, it bends like I've drawn it there. And if I do the opposite, if I go this way, right, then that beam will bend that way, right? Did I just draw the exact same one? No. Okay. Oh, yeah, that's better. Right, if I go like that, it bends the opposite way. Well, look here. That looks like a smile, and that looks like a frown. And don't smiles bring you up, but frowns bring you down. Right? And if the sum of the moments is 0, if that goes up, that goes down. If that goes down, then this goes up. And what do we learn from this? Well, let's look at it. That is what is that? That's clockwise. Okay? Clockwise is going up. Well, what about that one? Ooh, that's clockwise too, isn't it? This one's counterclockwise. So is that one. Okay? So here's a way to remember this, okay? This is how we're gonna make this moment just gonna jump on this graph down here, okay? Ready? Here you go. This is silly, but I bet you'll remember this, okay? In the kitchen, the clock is above and the counter is below. Okay? So in the kitchen, clock is above, the counter is below. Okay? So a clockwise moment is going to make me go up the graph. A counterclockwise moment is going to make me go down the graph. It's just a little silly trick to help you remember which way moments make me jump on the graph. So look here, I'll start off Now I'm on the moment diagram, right? I can use the graphic method on this. And the graphic method says this. Find the area of these shapes, right? Because the height of these shapes are in what? The height is in kips and the length is in feet. So if I multiply kips and feet, if I find the area, I have foot kips, which is, that's moment, isn't it? Okay. So this guy here is a rectangle that is what? 18 times 6. What is that on? 18 times 6 is 108. This bit down here is 108. And then this triangle is, shoot, I don't even know. 12 by 6, which is 72, divided by 2 is 36. So that total area plus 36 is 144. So this area here, 144. And then this little area over here is 8 by 4. It's 32. Okay? So that's going to help me do this down here. So here we go. I have 176 foot kips moment. This initial moment is what? Counterclockwise. And the counter is below. So guess what? Whoop! I'm going down. There I am, right there. At negative 176, right? Okay, I'm at 176 negative. All right. Now I got to go up 144. So 176 minus 144 leaves me with negative 32. And how do I get from there to there? Okay. Well, this line was a straight slope, right? Was this guy. So the next curve down is going to be parabolic. So the question is, the parabola, does it go like this or does it go like this? Is it this guy or that guy? Well, let's look at this curve up here. Are we going slow then fast or fast then slow? Because we're accumulating load, right? Because this is not a linear accumulation. I'm getting fat stacks over here and I'm getting short stacks over here, right? So this is fast then slow as far as the accumulation of moment goes. It's fast and slow. Okay, what would that look like on the ski slopes? Fast and slow. Would it look like that or would it look like that? Well, this one is steep and then it slows down. This one is slow down and then it's steep. So the bottom one is slow then fast. The top one is fast and slow. So guess what? It would be that top line, right? This is probably the #1 mistake I see my students making, is getting the inflection on these parabolic curves backwards. Okay? So something like that. All right, now we're at negative 32 over here. And then do we have we got a John Denver moment here that's going to take us home. Okay, so that's going to be 32 uphill, which takes me back to 0. And how do I get from there back to 0? Right? This one's straight across, so the next graph down is going to be a straight slope, right? So this is going to be straight. Okay, so we got a little curve there and a straight section there, okay? And that is what your diagram is going to look like, okay? The graphic method, pluses, minuses up here tells me uphill, downhill slope, and then just find the area of the shapes, and that tells you how much you're going to change on your graph. So there's a little example of the graphic method. I hope it helps. I'll see you on the next video.